Okay, notes on equations of parabolas with a focus and directrix. What is a parabola?
It's a curved linear line. It's not linear, but it's a line.
Yeah, we know that parabolas come from quadratics, right?
Yeah, that's what I said.
Now, I don't want to go away. There we go. A parabola is the set of all points that are equidistant from a special point called, actually no, it's not the vertex, called the focus. And line called the directrix. That's a new one. We've heard of focus. The line called the directrix. Yeah. Okay, do you still have room in that space? Let's define what a focus is. Again, a point which is directly above or below. In ellipses and hyperbolas, the focus we knew was inside. Where's the focus? Here we go. Inside the parabola-shaped part. Okay, I'll wait. Hyperbolas is also inside the parabola-shaped branches. Sometimes those are vertical, and sometimes they are horizontal, but it's always inside. So when we're dealing with just a basic parabola, same thing. It's a point directly above, inside the parabola, but it's always associated with where that vertex is. So a focus is a point directly above or below. Directly above or below the vertex, because our parabolas will only be concave up or concave down. They won't be sideways like hyperbolas are. So it'll have to be directly above or below. It can't be to the side. Okay, a directrix is any point on the parabola will be equidistant from the focus this is directrix relationship. Directrix relationship. Any point on the parabola will be equidistant from the focus and directrix. Any point on the parabola will be equidistant. Any point on the parabola will be equidistant from the focus and directrix. Bryson? Because it won't be a function. Parabolas are functions, so hyperbolas, ellipses, and circles so aren't functions. Okay. You guys ever used patty paper before? I tried this before. I didn't really get it to work very well. Let's see if you guys can get it to work better than I could. Take one of these, pass it down. So it's patty paper, like hamburger patty paper. Stick it between hamburger patties. Yeah. Okay, take one, pass it down. Nice and transparent. Your worksheet says, with a pencil, draw a point and a straight line on the patty paper. You need one more? Okay? So if you need help drawing a straight line, use the edge of your calculator or the edge of your worksheet. And. Okay, I'll wait till the conversations stop. Please hold them in. With a pencil, draw a point and a straight line on the patty paper. Then fold the paper multiple times, each time lining up the point on top of the line so that the fold is the same distance from each. So let me get a blank paper here. You need a straight line, and you need a point on your patty paper. Okay, so if I take a marker, line so we can see it, straight line, and a point. Everyone got a straight line and a point? Brian, sit up please. Fold the paper multiple times so that each time you're lining up the point on top of the line so that the fold is the same distance from each. Eventually the fold lines will begin to form a parabolic shape. Okay, so fold the paper so that it is equidistant from the point to the line. So when you're folding your paper, let these two folds be equidistant. No, they're not the same length. But maybe this fold and this fold, are those equidistant, are those congruent? Fold it straight through. And then maybe this fold and this fold. I'm showing you on here. And maybe this fold to the line. Fold it so it's equidistant. The point to the line, that length is equidistant. So it'll be like you're making an isosceles triangle with your line and that point. So those two folds, that length is pretty close to equidistant. Then I do another pair of folds. Okay, and then I do another pair of folds so that I take that one all the way through. And then I do another pair of folds until you have a handful of them. Just a handful. Okay, the point is that each time these are equidistant. This straight line you made is what is called the directrix. And no matter where you are on the parabola, you're always, as the definition of focus and directrix state, any point on the parabola will always be equidistant from the focus and the directrix. Any point on the parabola will be equidistant from the focus and the directrix. Okay, so I can't really do that on this one. But focus and directrix, actually, let's look at your notes. There's a picture already for us. This full line is your directrix. Go back to your notes, please. And write in, that's the directrix. This point inside the parabola is your focus. Any idea what this point on the parabola is? It's the center of the parabola, which we have a name for that. Vertex. And any point on the parabola would be equidistant from the focus and the directrix. Okay, so if I grab this point, that length is congruent to if I attach it to the focus, that length. Okay, this length is congruent to if I attach it to the focus, that length. You know what those tick marks mean, right? Congruence. And I can continue on for an infinite number of points in our focus, in the parabola. That's, any point on the parabola is equidistant. So the vertex straight down, that distance is equidistant to straight up to the focus. Same with our hyperbolas and ellipses. There's a relationship of distance there. Okay, so you can just put the patty paper to the side. Vertex, we need to change this word. This is standard form here. This needs to be vertex form. So scribble out standard and put vertex. Vertex form of the equation of a parabola. We've seen this a lot. Y equals a times x minus h squared plus k. Y equals a times x minus h squared plus k. That's called vertex form because you can see the vertex in the equation without even graphing. Because we do opposite, same. That would be the vertex. Opposite of h, comma, same of k. So the vertex is opposite of h, same k. Do you guys remember where the axis of symmetry is? Yeah, it goes vertically, that was supposed to be dotted, vertically through the vertex, and which coordinate does it always share with the vertex, the x-coordinate or the y-coordinate? The x-coordinate, because the vertical line slashes through the x-axis, so it shares the x-coordinate. And it's an equation, x equals whatever the opposite of h was. Because it will be the same x-coordinate, but it's an equation, x equals, yeah? Cool. Thank you. Okay, focus also shares the x. Because, if you notice, is my focus on the axis of symmetry? Yeah, and it's lined up with the vertex. They're all on the same vertical line. So the focus also, oops, spelled that wrong. The focus also shares the x. The focus is a point opposite of the h, same like the vertex, but it has the shift that the vertex has and then some. We call that plus 1 over 4c. We've used c before for the focus. right? We use Pythagorean theorem to find C sometimes, and C was from the focus. Okay, and the directrix, to find the directrix, it's an equation of a line. Directrix is horizontal. If you have a horizontal line, you're going to slash through which axis? The y-axis. So it's y equals k minus 1 over 4c. We're going to actually use these formulas here in a minute, so you can know what they do. Okay? So, directions for the 3 examples down below. Identify the vertex, focus, axis of symmetry, directrix, and direction of opening of each. Is it concave up or is it concave down? We're not there yet, okay? Okay, number 1. Here's our equation. It's not in the right form, though. We need to get it into this form that's written up above, vertex form. Y equals everything else. Okay, Kaylin, how would you get A to be in the correct form? It says 1/2 y equals x squared right now. We just want it y equals. You can divide by 1/2, and that's the same thing as timesing by 2. So to avoid all the fractions, I'm going to go with timesing by 2. But dividing by 1/2 also works. Okay? So I'm going to put a yield sign. You can't put an equal sign because it's not equal. You need to put y equals, I guess it could be equal, 2x squared. Put a yield sign. These arrows are mathematical yield signs. Okay? Y equals 2x squared. Okay? So that is our vertex form. From that, we should be able to see the axis of symmetry and the vertex. Let's start with the vertex. Remember, the vertex is the opposite of what's being added or subtracted to the x, the same of what's after the squared. Opposite, same. What number is in the parentheses here being added or subtracted to the x? 0. There's not parentheses and there's not a number. What number is after the squared? 0. So your vertex is 0, 0. The vertex is 0, 0. Axis of symmetry is an equation. X equals. What was the x of the vertex? What was the x of the vertex? 0. So it's x equals 0, which means it slices through the x-axis at x equals 0. Okay. Now for, let's see. Oh, we didn't do, I missed one vocabulary word up here. Okay. Sorry, there's one more. Length of the lattice rectum. Length of the lattice rectum is the absolute value of 1 over c units. Because length has to be positive. Okay, C comes from the slope. I guess we've also called it A here. But C and the A are interchangeable, okay? The C part just comes from, what's the multiplier? Okay, make a note that C, we normally call it A, so I'm not going to change it. But this C is the A. So in our case, on example 1A, what is C going to be? What number? 2. 2. So the length of the lattice rectum, sure, equals 2. So now that we know C, actually 1 over, absolute value 1 over 2. C is 2. The length of the lattice rectum is absolute value 1 over 2, which is just 1/2, right? Positive 1/2. Okay, now that we know C, we can find the focus. Focus is a point. The focus always shares the same x with the vertex and the axis of symmetry. So what's the x-coordinate of the focus? 0. Comma, it's shifted up. The focus has the y-coordinate of the vertex plus 1 over 4c. What was the y-coordinate of the vertex? It was also 0, but we have to add, because it's above or below, 1 over 4 times c. What was c? 2. So that means our focus is going to be at the point 0, 1/8, because 0 plus 1 over 4 times 2 is 1/8. And the last thing we need is the directrix, and then we can graph it and determine if it opens up or down. Directrix. When the guy at the football stadium is holding the parabolic sound sphere thingy, his body is the directrix, because it's vertical, which means the sphere is going out this way. If it was off the floor, like if we had a floor, the parabolic shape would be up here. Okay, so if it's concave up, then we have a flat, or even concave down, then the directrix is horizontal. For all of our graphing purposes, because it has to be a function, it's always horizontal. Okay, the directrix was y equals, because it's a line, k. What is k? It comes from the vertex. What was our k in this case? 0, but it's minus 1 over 4c. For the vertex is plus 1 over 4c. So instead of positive 1/8, the directrix will have 0 minus 1/8, which is negative 1/8. So the directrix is 0, negative 1/8. Okay, let's get everyone needs 2 colored pencils so we can graph all of these. Take 2, pass them down. Uh-oh, I'm missing a box. Nope, here it is. Take 2 colored pencils, pass them down. Okay, let's just go down in order of what we know. We know the vertex is 0, 0, so take a color, plot 0, 0, and maybe label it V. Vertex, 0, 0, label it V. You can do different colors if you want. Now let's find the focus, 0, 1/8. I'm going to do that in a different color. 0, 1/8. How far above the origin is 0, 1/8? Not far at all, just barely, barely above it. And that's the focus, F. Okay, the axis of symmetry. I would choose a different color for axis of symmetry. Is a line cutting through the x-axis at 0. X equals 0. Guys, come on. X equals 0. So you just need to do a dashed vertical line. That's your axis of symmetry. X equals 0. We also have another line. Whoops. I put the directrix as a point. That's not true. It's an equation. Oh, don't move, don't move, don't move. It's an equation. Y equals 1/8. So where we slash through the y-axis at negative 1/8, which is just barely below the x-axis. This is the directrix. Y equals negative 1/8. Okay, the only thing we're really missing is the parabola. Now, a quick way to get points would just be to do a table of values, because we already know how to do x, y tables, but that's not what our lesson's on today. So, grab your calculator. If you need one, come get one. Go to y equals, type in the function 2x squared. Then, above graph, what does it say in yellow or blue, depending which calculator you have? Table. If you go to table, you can get your points. Go second graph, and that will give you the table of values to plot for the parabola. I would make sure the vertex is in the middle. Guys in this corner, please stop talking. You go to y equals, and you put in your 2x squared, the function. Y equals 2x squared. Then you go second graph. It'll give you the table of values for all the points you can plot. Make sure the vertex is in the middle. 0, 0 should be shown. I need a couple to the left of 0, 0. What's the y value we get for negative 3? Negative 3, comma 18. Well, that's not on my graph, so let's try another one. Negative 2, comma, also not on my graph. Negative 1, comma, that one's there. And then we have the vertex, which we've already plotted, 0, 0, and then 1, comma, 2. That's a fast way to get the points, because the point of this assignment is not to learn how to write a table of values. It's to learn how to do the focus and directrix. Okay, so you can get your table of values really quickly by just plugging it in. Yeah? Did you go to y equals?
Yeah.
Did you type in 2x squared? Did you go second graph? Those are your x and y values for the graph. All you have to do is plot them on the graph.
So then there's the graph.
Go second graph. You need the table. Okay, we're going to try one more. Okay, we're going to try one more, part B. Okay, first you need to get it in the right form so we can see the vertex. Which means we need to solve it for y. It's definitely not solved for y right now. Kayla, how would you begin solving this part B for y? When you get y by itself, what are some things by y that need to be moved? Well, we don't want to distribute in. We want to move them away. We don't want to add them to the y. We want to move them away. What's something that needs to be moved? What's next to y? Negative 8. How do we move it? To the left. What's the inverse operation? Divide, because this is times, right? So the inverse is to divide by negative 8. Now, negative 8 is going to become your a. So I have y minus 2. Dividing by negative 8, is that the same thing as negative 1 over 8? Dividing by negative 8 is negative 1 over 8. And then I'm going to put my parentheses. That way I'm setting it up in vertex form. Okay, Brian, how do I get y by itself now? Plus 2, both sides. Now, anything that's being added or subtracted should go on the far side, because that is your vertical shift. So this is vertex form. Y equals negative 1/8 times x plus 1 squared plus 2. You can see your A, which is also called our C on this. You can see your H and your K, your horizontal shift and your vertical shift. If you need to go into the space of C, you can do that, because we're not going to do C. So if you need that space, use it. Okay? Would you turn to your neighbor, please, and tell him what the vertex of this quadratic is? Okay? Now show me with your partner, fingers in the air, what is the vertex you came up with your partner, because you need 3 hands. With your partner. Make sure it's in the right way for me to see. Good. Should be -1. Oh, they even have the comma. Way to be. 4 hands. -1, comma, 2. Excellent. Okay, please turn to your neighbor and tell them what the axis of symmetry is. And you better say an equal sign, because it's an equation. Turn to your neighbor, please tell them what the axis of symmetry is. Back row, folks, stop. What's the axis of symmetry? It's an equation. Connor? Okay. Let's see. In the back row, you 4, what's the axis of symmetry? I didn't hear an equal sign. I don't think 1 is in the vertex. It goes through the -1 or it goes through the 2. So what's the equation? X equals, and it can't be 1. It has to be -1. Did you just get your wisdom teeth out or something? Yeah. You're just kind of mumbling. Okay. X equals -1. Axis of symmetry is a vertical line that slashes through the x-axis. So it has to be x equals. And the only x from the vertex is -1. Okay? Let's get the focus. Okay, the focus has the same x value, so it's a point. What's our x coordinate? -1. So if you notice, these 3 all have a -1. Comma, Brian, please be writing. We start with the y value of the vertex, which was a 2, but then the focus is either added or subtracted. It's either above or below the vertex. We have to adjust it a little bit. And the focus, we'll have it up here, is k plus 1 over 4c. What was c slash a? I should change that, so we just use a. What was the a? -1/8. So we need 2 plus 1 over 2 plus 1 over 4 times -1/8. Whew. So let's do that work over here. Erase this. How does that fraction simplify? 1 over 4 times -1/8. That's the same as 1 over -4/8. How do we divide by a fraction? Not just multiply. Flip. Flip and multiply. So we have 1 times the flip. What's the flip? -8 over 4, which is -2. So this ends up being, right here, 2 plus 2, which is just 4. So our focus is -1, comma 4. That's the focus. Now, you can go through all that process again. The directrix is the exact same distance if our vertex is here And our focus is here. The vertex was at a height of 2. The focus is at a height of 4. What's that distance? 2. So that space is 2. The directrix has to be the exact same space below it. So if this is at 2, what's the height of the directrix? 0, because that has to be a distance of 2. Or you could go through the same process for the directrix and do -1, comma 2. The only difference between the focus and directrix, focus is add, directrix is minus. 1 over 4 times -1/8, woo, which we know was 2. So we would get -1, comma 0, because 2 minus 2 is 0. Well, if you already know the focus and it came out as a pretty number, then just take that distance and subtract it from the vertex height, and then you have the directrix. Oh, it's not a point, huh? Whoops, I did the same mistake. It is an equation, but it's a horizontal line. Horizontal line sliced through which axis? Y equals 0. So this should not be -1. That should be y equals like that. Okay, I think we're ready to graph, and then we'll use our calculator to get the other points. What? It says y equals 0. No, because 2 plus, oh, it was -2. Oh, it's backwards. Okay, so just label this one directrix. No. This is 2 minus 2. Yeah, so this is the directrix. Y equals 4, and this one's the focus. The reason this was 2 minus 2. We got a -2. I thought it was a +2 over there. This is 2 minus 2, because that was a -2, which ends up... What? Oh my heck, what has gone wrong? Okay. I'll clear it up. All you really have to do is relabel. Directrix was y equals 2 minus 1 over 4 times that -1/8. And this fraction became -2, which is 2 minus a -2, which is 4. Y equaled 4. So all you have to really do is relabel what you had in your paper. The focus is a point, -1, comma, 2 plus that fraction, 1 over 4 times -1/8. So our focus is a point, -1, comma, 0. We just had the 0 on the directrix, and the 4 and the 0 were flip-flopped. Okay, grab your colored pencils first, graph the vertex. -1, comma, 2. I put a little V, so you remember what that was. The axis of symmetry is a line. X equals -1. And we show the axis of symmetry by doing a dashed line because it's a fold line. Axis of symmetry is x equals -1. It should go through the vertex. If it doesn't go through the vertex, then something's wrong. Okay, next we have a directrix. Y equals 4. Y equals has to slice through the y-axis at 4. That's the directrix. Y equals 4. What else do we need to put on this? The focus. It's a point. Focus is -1, comma, 0. And it should be either directly above or directly below the vertex. Are these directly above and below each other? the vertex and the focus? Okay, make sure they are. And it should also be on the axis of symmetry. Now the only thing we need that's remaining is the points of the parabola. So go to your calculator, go to y equals, and type in the vertex form that we got. That's right here in red. However, if you have a fraction, you have to use parentheses. So go to y equals, and I would put parenthesis, -1 divided by 8, close the parenthesis. That fraction needs to be in parentheses. Times parenthesis, x plus 1, close the parentheses, squared. Whoa, whoa, did you see that catch? That was impressive. Plus 2. So again, in parentheses, -1 divided by 8, close the parentheses. Times parenthesis, x plus 1 squared, with that close parenthesis, plus 2. Then you go second graph, and it will give you the table of values for you to plot. Okay, you have some decimals, that's okay. They can plot decimals. Now, okay, this is important. Everyone's calculator is going to be in a different place. You can use the up and down arrows until you put the vertex in the middle of your screen. The vertex is -1, 2. So use the up and down arrows until the vertex is in the middle. And then that screenshot you see, those are the points you should plot. Okay, we have the vertex, which is -1, 0. A nice point is -3, 1.5. -3, 1.5. That's a pretty decent point to plot. I think -5 would probably even be good. -5, 0. Another nice point was 1, what's the y coordinate that goes with x equals 1? 1.5. And then we use symmetry. That was 1, 1.5. And then we have some symmetry, and we have 3, 0. That's also a nice point. Connect those with a parabola, then your graph is done. These two have something different about them. The first one is concave. Which direction? Up, because it's pointing up. Concave up, because the A was positive. When it's concave up, the directrix is below the vertex. The second one is concave down, and the directrix is above the vertex. So the directrix should not be inside the parabola. Okay, let's take a quick drink break. Stand up, take a break.